Hello, in this video, I'll show you how to use the Google Play billing library to start selling in-app products in your apps. We'll go over how to add in-app products from the Google Play console, launch a purchase flow UI to allow users to purchase the item, verify the purchase with a backend server using Firebase Cloud Functions and the Firestore Database, acknowledge the purchase to finalize and receive the payments, and then we'll unlock the product so users can purchase the same item again. To begin, go to the manifest file and add the internet permission. Then go to the app's build Gradle file. In the dependency section, implement the Google Play billing library and sync the project. When finished, go to the Build tab at the top and generate a signed app bundle. Once the process is complete, go to the Google Play console and set up for testing. Go to play.google.com/console. On the left, under Setup, go to License Testing and add your testing account. Then go to the All Apps page and click on the Create App button to create the console page for your app. When you're in your app's console page, scroll down until you find the Internal Testing tab on the left. Click on the Create New Release button and upload the app bundle. When the upload is finished, scroll down and give the release a name. Save the changes. Click on Review Release, and then start rollout to internal testing. When the release is created, click on the Testers tab and add the testing account that you added earlier in the license testing page. The next step we need to do is to have an emulator that supports Google Play. Open the Android Virtual Device Manager. If your emulators do not have a Play Store icon next to it, you will need to create one that does. Click on the Create Virtual Device button. Select the emulator with the Play Store icon and complete the process. Start the emulator. Open the Google Play app and sign in with your testing account. The last step we need to do is to opt in as a tester. Go back to your app's console page. In the internal testing tab, scroll down until you see the section called How Tester Join Your Test. Click on Copy Link and open the Chrome app in the emulator. Paste the link in the address bar and then accept the invite to test the app. Now that the setup is complete, we can start using the Google Play library. To add products to your app, go to your app's console page and scroll down until you see the Monetize section on the left. Under Products, click on In-App Products, and then click on the Create Product button on the right. On this screen, we can enter the ID, name, description, and price of the item. The product ID is a unique name for the product. It cannot be changed or reused in another item once it is created. In the Product Details section, the name and description are used to describe the item. For the price, click on Set Price and enter a price for the item. Click on Apply Prices, save, and then activate to complete the process. If we go back to the in-apps product page, the new item should be there. Repeat the steps one more time so you have 2 items for this video. Now that we have some items, let's see how we can display it in our app. Go to the main activity file of your project. Declare a billing client variable and use the new builder and build methods from billing client to create the object. The billing client object is used to communicate with the Google Play's billing system. We can use it to get all the information from the products list. Before we can connect to Google Play, it is required by us to support pending purchases. Call Enable Pending Purchases right before we build the client, and add a Purchases Updated listener so we can handle all the incoming purchases from the user. Now that we have our billing client, create a method called Connect to Google Play Billing. Inside the method, take the billing client object and call Start Connection. It takes in a billing client state listener that is used to check if we are connected to the Google Play's billing system. It is advisable that we restart the connection if we have disconnected. Call the Connect to Google Play Billing method inside the onBilling Service Disconnected callback. The onBilling Setup Finish callback is used to let us know what the current connection state we're in. If the response code we receive from the billing result object is OK, it means we have connected to the Google Play's billing system. To get the products that we have added in the Google Play console, create a method called getProductDetails. And then call it inside the onBillingSetupFinish callback. Inside the getProductDetails method, create a list called product IDs. And add the product ID for each product you have in the Google Play console. For now, I only want to show one item, so I'll just add one. Once you have the list of product IDs, call query SKU details async from the billing client to actually get the product information. It takes two arguments. The first asks for a SKU detail params. We use it to generate a query to get the product details using the list of product IDs we have. Declare a SKU details param variable called getProductDetailsQuery. And call the new builder and build methods from SKU details param to create the object. Call setSKUsList to add the list, and call setType to set the type. Then insert the query object into the query SKU details async method. For the second argument, it takes in a SKU details response listener that we can use to access the result from the query. The list object represents the product information we request. Use an if statement to check if the billing result was OK and if the list is not null. Now that we have retrieved the product's information, we can display it so users can see it. Normally, you'll use a recycler view or a cart view to display the items, but since we only have one item, we will use a text view to display the item's name and a button to display the price. Go to the main activity XML file and add a text view and button inside. Set the constraints so that the button is on the right and the text view is on the left. Rename the text view ID to item name and the button to item price. Go back to the main activity file. In the SKU details response callback function, create a reference to the text view and button. Since we only have one item, create a single SKU details variable and get the first item in the list. Then set the text of the text field by getting the title, and the button by getting the price. Do not forget to call Connect to Google Play Billing after the billing client is created. If we run the app, we should see the item. Now that we have a way for users to see the item, we want them to be able to purchase it. Add a on-click listener to the price button. We want to launch a purchase flow UI so users can choose how to pay for the item when they click on the button. Grab the billing client and call launch billing flow. It takes two arguments, a context and a billing flow params object. Use the new builder and build methods from billing flow params to create one. Then call setSKU-details to add the item details before building it. If we run the app and click on the item, a purchase flow UI should come up. Now let's see how we can verify the purchase when the user pays for the item. Whenever someone pays for an item, it'll bring us back to the onPurchases updated callback. The billing result object returns the status of all the purchases made, and the purchase list represents all the purchases that were made by the user at that time. This is where we need to place the code to verify the purchase through a backend server and acknowledge the payment to receive the money. First, make sure that there is a successful purchase. Check if we got an OK response code, and then check if the purchase list is not empty. To verify if the purchases are real, it requires two steps. The first step is to make sure if the item is in a purchase state and it is not acknowledged before. Use the for loop to iterate through all the purchases that are coming in. Then use the if statement to validate the state and acknowledgement. The second step is to verify the purchase using a backend server. We will need to get the purchase token for each purchase, send it to our backend server, and then check if the token was never used. If the token was never used, it means it is a valid token. When we verify that the token is valid, we can store that purchase information in an online database and send a message back to the app to notify the user. For this part, we'll use Firebase Cloud Functions as the backend server and Firestore as the database. Begin by creating a Cloud Functions project. Go to console.firebase.com, sign in with your Google account, and create a project. If you do not have a Google account, go to accounts.google.com/signup to create an account. Once you have created a project, make sure you have Node and Firebase tools installed on your computer. Run node-v to get the version of Node you have installed, and Firebase -- version for Firebase tools. If you do not have them installed, go to nodejs.org and follow the steps to install Node. For Firebase tools, run npm install-g Firebase tools after you have Node installed. When you have Node and Firebase tools installed, create a folder where it is easy to locate. Open a terminal for that directory and log into Firebase. Afterwards, initialize Firebase Cloud Functions using Firebase init. Select the Firebase project you have for the app and continue. Select Yes to install the dependencies and continue. Once Cloud Functions is set, open the project in the code editor. Expand the Functions folder and go to the index.js file. In here, we can define our validation functions. Type exports, then use the dot operator to name the function. And then assign a request handler function to it. To store the tokens data that we're receiving, create a JSON object called purchase info. It should contain at least 4 properties: purchase token, order ID, purchase time, and is valid. To get the purchase token, grab the request object, call query, and then access the purchase token property. For order ID and purchase time, we'll do the same. For is valid, set it to false as the default value. Now that we have the purchase information in a JSON object, we need to connect to Firestore and check if the token was used or not. Import the admin module and initialize the app. Inside the validate function, create an instance of Firestore by taking the admin object and calling the Firestore function. To check if the token exists in Firestore, we just need to see if there's a document with the same token ID as the current token. If there are no such document, it means it is a new token. Grab the Firestore object, call doc, get, and then. Inside the doc function, enter the path to the collection where you will store all your purchase information. Use the purchase token as the ID of the document ID. For then, pass in a function with a result parameter. The result parameter represents the document that was retrieved from Firestore. We can use the assist property to check if there was a document with the same purchase token. If there is, send the purchase information back to let the app know that it was not a valid purchase token. If it does not exist, we want to add the purchase information to the database. Set the isValid property from the purchase information object to true. Grab the Firestore object, call doc, set, and then. Inside the doc function, pass in the same path to the document. For set, pass in the purchase information object. And for then, pass in a function and send the updated purchase information back. This is all we have to do to validate the purchase. The next step is to upload this function to Cloud Functions so we can use it. Open the terminal and run the deploy command. Make sure your Firebase project is upgraded to the Blaze plan before executing the command, or you will not be able to deploy the function. Once the deployment is completed, go to the Firebase console. In the Functions tab, you should see the function in the system. Copy the request URL for the function and paste it inside the Android project so we have it. We will need to use it to send data back and forth between the server and the app. The idea is to call the function in the server using the request URL, and when the server is done doing whatever it needs, it will send a message back to us to let us know whether the purchase was valid or not. To communicate with Cloud Functions using the request URL, go to the apps build Gradle file and implement Volley. Go back to the main activity file and create a new method called verifyPurchase with a purchase object parameter. Inside the method, create a string variable for the request URL. If we take a look at Cloud Functions, we're trying to get the purchase token, purchase time, and order ID from an object called query. To add data to the query object, we need to add a question mark symbol at the end of the URL to represent the start of the query parameter. For each set of data, we need to insert a key and value pair and separate each set with an ampersand symbol. Make sure that the name of each key is identical to what you have defined in the JSON object in Cloud Functions. Now that we have our URL set up, create a post request using string request from the Volley library. It takes 4 arguments. The first is the type of request we're trying to make, and we're trying to make a post request. The second argument is the request URL. The third argument is a response listener callback function, which will be called when we receive a response back from the server. And the fourth argument is a callback for errors. Now that we have our request set up, we need to send it to the server. Create a request queue using new request queue from Volley. And add the string request to the queue. Remember to call the verifyPurchase method inside the onPurchases updated callback. Go back to the Firebase console and change the Firestore rules to true to allow us to read and write to the database. If we run the app and purchase the item, it should be uploaded to Firestore. If we try to purchase the item again, we'll get an error. This is because all in-app purchases are defaulted to one-time purchase only. In order for us to actually get the money for each purchase, we need to acknowledge it either by calling acknowledgePurchase or consumeAsync. We use acknowledgePurchase if the product is a one-time purchase item, and we use consumeAsync if the item is purchasable multiple times. Let's see how this is done in code. Go back to the verifyPurchase method. Inside the response listener callback, create a JSON object using the response from the server. Then use an if statement to check if the isValid property is true. If it is, we can start acknowledging the purchase. To use acknowledgePurchase, create an acknowledgePurchase param object. Use the new builder and build methods from acknowledgePurchase param. Then add the purchase token of the purchase you want to acknowledge using setPurchaseToken right before we build the params object. Grab the billing client and call acknowledgePurchase. Pass in the purchase params, then add an acknowledgePurchase response listener. Inside the response listener, check if the result was OK. If it is, we need to put the logic to notify and give the item to the user. For now, we'll use a toast message. If we run the app and purchase the item again, it will get acknowledged. If you're getting an error that says you already own the item, wait a few minutes for it to reset and try again. Now let's see how we can acknowledge consumables. Go back to the getProductDetails method. Replace the old item with a new one. To acknowledge consumables, we need to use consumeAsync instead of acknowledgePurchase. It takes two arguments. The first is the consumeParams object. Create one by using the new builder and build methods from consumeParams. Then add a purchase token by calling setPurchaseToken. The second argument is for the consumeResponseListener. Inside the response listener, check if the result was okay. If it is, we need to put the logic to notify and give the item to the user. For now, we will use a toast message. If we run the app, we can purchase the item multiple times. This is all we need to do to verify the purchases, but as best practice, we should not rely solely on the onPurchases updated callback. This is because the callback will only be available when the app is open. To handle purchases that were made while the app was closed, we need to override the onZoom method. The idea is to retrieve all the purchases when the user returns to the app, and then we will verify each purchase accordingly. Inside the method, grab the billing client and call the queryPurchasesAsync method. The queryPurchasesAsync method returns the purchases made by the user. It takes two arguments. The first argument is the type of product we want to get. The second argument is for a purchases response listener, which gives us access to the result of the query. Use the billing result object and check if the status was okay. Inside the if statement, iterate through all the purchases that were made, and then check if the state was purchased and not yet acknowledged. If it was not acknowledged, we want to verify the purchase. That's all for this video. If you found this video helpful, please give it a like, share, and subscribe to support the channel. See you in the next video.